Welcome to Analytics Campus. This is Dr. Mike. Today I will be discussing and illustrating exploratory data analysis, also known as EDA. If you are new here, please subscribe, like, and feel free to share. Exploratory data analysis was promoted by John Tukey to encourage statisticians to explore data and possibly formulate hypotheses that might cause new data collection and experiments. EDA focuses more narrowly on checking assumptions required for model fitting and hypothesis testing. It also checks while handling missing values and making transformations of variables as needed. The diagram below depicts the fundamental steps of exploratory data analysis. Types of exploratory data analysis: univariate non-graphical, multivariate non-graphical, graphical, univariate graphical, multivariate graphical. Univariate non-graphical. This is the simplest form of data analysis, as during this we use just one variable to research the information. The standard goal of univariate non-graphical EDA is to know the underlying sample distribution of data and make observations about the population. Outlier detection is additionally part of the analysis. The characteristics of population distribution include central tendency. The central tendency or location of distribution has got to do with typical or middle values. The commonly useful measures of central tendency are statistics called mean, median, and sometimes mode, during which the most common is mean. For skewed distribution or when there is concern about outliers, the median may be preferred. Spread. Spread is an indicator of what proportion distant from the middle we are to seek out the data values. The standard deviation and variance are two useful measures of spread. The variance is the mean of the square of the individual deviations, and therefore the standard deviation is the root of the variance. Skewness and kurtosis. More useful univariate descriptors are the skewness and kurtosis of the distribution. Skewness is the measure of asymmetry, and kurtosis is a more subtle measure of peakedness compared to a normal distribution. Multivariate non-graphical. Multivariate non-graphical EDA technique is usually used to show the relationship between two or more variables within the form of either cross-tabulation or statistics for categorical data. An extension of tabulation called cross-tabulation is extremely useful for two variables. Cross-tabulation is performed by making a two-way table with column headings that match the amount of one variable and row headings that match the amount of the other two variables, then filling the counts with all subjects that share the same pair of levels. For each categorical variable and one quantitative variable, we create statistics for quantitative variables separately for every level of the specific variable, then compare the statistics across the amount of categorical variable. Comparing the means is an informal version of ANOVA, and comparing medians is a robust version of one-way ANOVA. Univariate graphical. Non-graphical methods are quantitative and objective. They do not give a complete picture of the data, therefore graphical methods are more involved. A degree of subjective analysis is also required. Common types of univariate graphics are histograms. The most basic graph is a histogram, which is a bar plot, in which each bar represents the frequency count or proportion count, total count of cases for a range of values. Histograms are one of the simplest ways to quickly learn a lot about your data, including central tendency, spread, modality, shape, and outliers. Stem and leaf plots. An easy substitute for a histogram may be stem and leaf plots. It shows all data values and the shape of the distribution. Box plots. Another very useful univariate graphical technique is the box plot. Box plots are excellent at presenting information about central tendency and show robust measures of location and spread, also as providing information about symmetry and outliers, although they can be misleading about aspects like multimodality. One of the best uses of box plots is in the form of side-by-side box plots, quantile normal plots. The ultimate univariate graphical EDA technique is the most intricate. It's called the quantile normal or Q plot, or more generally, the quantile-quantile or QQ plot. It's used to see how well a specific sample follows a specific theoretical distribution. It allows detection of non-normality and diagnosis of skewness and kurtosis. Multivariate graphical. Multivariate graphical data uses graphics to display relationships between two or more sets of data. The only one used commonly is a grouped bar plot, with each group representing one level of one of the variables, and each bar within a group representing the amount of the other variable. Other common types of multivariate graphics are scatter plot for two quantitative variables. The basic graphical EDA technique is the scatter plot, which shows one variable on the x-axis and one on the y-axis, with a point for each case in your dataset. Run chart. It's a line graph of data plotted over time. Heat map. It's a graphical representation of data where values are depicted by color. Multivariate chart. It's a graphical representation of the relationships between factors and response. Bubble chart. It's a data visualization that displays multiple circles or bubbles in a two-dimensional plot. In a nutshell, you should always perform appropriate EDA before further analysis of your data. Perform whatever steps are necessary to become more familiar with your data. Check for obvious mistakes. Learn about variable distributions and study relationships between variables. If you enjoyed my teaching, give me a thumbs up, subscribe, like, comment, and share. Thanks for watching. Check out my other tutorials and illustrations.